Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at a couple of exponent laws. First, we're going to take a look at product of powers, and then we're going to take a look at a quotient of powers. Now, for a product of powers, product meaning the answer to multiplication, when we multiply powers with the same base, meaning that the bases are the same value, except they can't equal 0, we keep the base, and then we add the exponents. So here we have a to the m times a to the n. So we're going to keep the base, a, and then we're going to add our exponents, m plus n. Let's take a look at this in an example. So here, the first note is evaluate. So when I ask you to evaluate, or when a question asks you to evaluate, it means to find the answer in standard form. So here we say to evaluate 5 cubed. So 5 cubed means 5 times 5 times 5. And we can see that's 125. Now, if you have 5 cubed times 5 squared, if I expanded each one separately first, we can see that's 5 times 5 times 5 for the 5 cubed times, and then 5 times 5 for the 5 squared. So really, this just means that we have 5, and then there are 5 5s, so it'll be 5 to the power of 5, and that equals 3,125. So, to reiterate the rule, we can take 5 cubed times 5 squared, and we can say there are 3 5s and 2 5s, and we can simply add the exponents together, so that would be 3 plus 2, which will give us an exponent of 5. So now we have 5 to the power of 5, which will then give us our answer of 3,125 in standard form. Now note number 2 says to express as a single power. That means that we want to leave our answer in exponent form with only one power. So in this example, we have 8.3 to the 7 times 8.3 to the power of 4. So the bases are the same, so this will be 8.3. And then we're going to add our exponents, 7 plus 4. So that's going to equal 8.3 to the power of 11. So you can go straight to the power of 11 if you know how to add the exponents. So let's do a few examples. We have 2 cubed times 2 to the 4. So that's 2 to the 7. So that's our single power. And remember, to evaluate means to write this in standard form. So 2 to the 7 means we're going to have 2 times 2 times 2 times 2 times 2 times 2 times 2. So 7 2s. And that's going to be 128. And the next one, we have 8 as our base. And then 7 plus negative 7 is going to give us 0. And if you recall, any power with an exponent of 0 is equal to 1. All right, and the last one here, we have a common base of negative 3, and we're going to add our exponents. So 4 plus 2 is 6. And then negative 3 to the power of 6 means that we have 6 negative 3's multiplied together, and that actually gives us 729. So that's how you use and apply the product of powers law. All right, next we're going to take a look at the quotient of powers. So to divide powers with the same base, except that the base can't be 0, we keep the base like we did with multiplication, but this time we're going to subtract the exponents. So we have a to the m divided by a to the n. We keep the base a, but this time we're going to go m minus n with the exponents. And then again, a cannot equal 0. So let me show you how to do this as an example with this first question here. So you have 2 to the 5 divided by 2 cubed. Now, if I write this actually in fraction form, this would look like this. So I have 5 2's in the numerator, divide, and that's for the symbol division here. And then we have 3 2's in the bottom, and we can reduce. So we can cross off 3 2's, 3 on the top, 3 on the bottom, and now I can see that I have 2 times 2, which is 2 squared, which equals 4. Now, instead of doing all of this work over here, which I'm going to highlight, I can actually just use my Quotient of Powers Law, which means that if the bases are the same, I can subtract the exponents. The bases are the same here, which is a base of 2, and I'm going to subtract 5 minus 3, which gives me 2. So let's try that for the next one. So I have 3 as my base, and then my exponent is 2 minus negative 2. Now always be careful with the subtraction. Students tend to make more mistakes with subtraction because of the minus sign. So notice that the 2 negatives we're going to actually add. So let's change it to plus. So now we have 3 to the power of 4, and that equals 81. Okay, in the last one here, we have negative 8. Exponent is 4 minus 4, which is 0. And then anything to the power of 0 is 1. All right, finally, we're going to finish off with a few problems where you have to apply more than one exponent law. All right, so here we have 3 questions where the instruction says to write as a single power. So in all 3 of these questions, we can see that there are 3 powers, but we want to combine them to make them 1. So with this first one, let's do 2 to the 5th times 2 to the 4th first, because times is coming before our division. So we're going to use our product law, and we're going to have a base of 2, and then 5 plus 4 is 9. And then we're going to divide by 2/3. We're going to bring that down. Now this time we're dividing, and when we divide, we keep the base the same, but this time we're going to subtract our exponents. So now we have 9 minus 3, which is 6. This one doesn't tell us to evaluate, so we're going to leave this answer as 2 to the power of 6. All right, now notice for B, the numbers or the powers are the same, but I've swapped the division and the time symbol. So this time we're going to do the division first. So we're going to say base of 2, and we're going to go 5 minus 4, because we're dividing, and when we divide, we subtract our exponents. So that will be 2 to the power of 1, and then times 2 cubed. And again, now we're going to multiply. So we have the base of 2, but this time we're going to add the exponents. So it'd be 1 plus 3, which equals 4. All right, in the last one here, we always work with the numerator separately until we get a single power, and then we'll work with the denominator until we get a single power. Sometimes you can mix and interchange them, but I find it easier to sometimes just work with each separately first. All right, so in our numerator, our base is 8, and we're multiplying, so we're going to add our exponents. So 7 plus 5 is 12. In the denominator, I have 8 to the negative 7. And now we're going to subtract because we are dividing. This is our division line. So we have 8 to the power of 12 minus, don't forget, and it's negative 7. So I'm just showing the in-between step here so that you can see what's happening. So we have minus a negative 7, so that's the same as adding the 7. So now we have 8 to the power of 12 plus 7, which is 8 to the power of 19. And that's how you apply quotient of powers, and then also when you have a quotient of powers mixed in with a product of powers.